Okay, so today we're going to continue with our function exploration, and we're going to start with some domain and range conversations. Okay, some domain and range conversations again. Remember, your domain is your x value and your range is your y value. Okay, so this first one we see we have open circles again, and I'm going to kind of draw some lines here. I'm going to stop, that's where it stops on the x-axis, and then this is where it starts on the x-axis over here at 1, 2, 3, 4, -5. Okay, so domain is my x's. So with the x's, I see that it is starting at the -5. So the -5 is going to go on this side, and it's an open circle. So I know that I'm going to the right from there. So that's going to be x is greater than -5. Remember, this is a compound inequality. I'm going to go all the way up to the 3. And then I'm going to go back to the left. So that's going to be less than. Remember, when you're on a compound inequality, they always point to the left. All right, now let's look at the y's. We're going from here to here. So I'm starting at what value? 1, 2, 3, 4. So I'm starting at 4. Again, it's an open circle, so it's going to be less than. And it's going down 1, 2 to the -2. So this could be real numbers, the -2, the 4, and it could be real numbers, the 3 and the -5. It doesn't change. Okay, this one's a quadratic. And quadratics don't have stopping points and starting points as much as these start and stops do. Okay, so the domain, again, is all real numbers. It didn't change. It's going to continue on forever. But the range, this has a minimum or a bottom. So it is stopping right there at -1. So since I am starting with real numbers and I have the value of -1, am I going less than -1? Am I going more than -1? I'm going up, so that's going to be greater than or equal to -1. I could also write that as y is greater than or equal to -1. Okay? Okay, let's see what we can do with this one. So I'm going to draw some lines. Here's my x's. I'm starting with a closed circle. I'll throw my x in there. I'm starting at -2. And it's equal to, because it's a closed circle, I'm going 1, 2, 3, 4 as an open circle, so I'm stopping at the 4. And again, this could be the real numbers, or it could be the x. All right, let's take a look at the y values. It's going between these two numbers, okay? So I'm starting with the 1 to -3, and I have a y value, and I see that it's going to be closed because there is a closed circle there. And we do have an open circle and a closed line. So I'm going to go ahead and call that a closed because that kind of supersedes it. I'm going 1, 2, 3. So I'm between -3 and +3. Okay, what about the domain on this guy? So I see it's starting over here at 1, 2, -3, and it's going this direction. It goes on forever. So that means I'm using every number that's bigger than -3. So if I'm using every number bigger than -3, I can say real numbers greater than -3. Now this one's not greater than or equal to because that is an open circle. All right, what about the range? Well, it's starting down here at 1, 2, 3, -4, but it is going up, and this is going to continue. So it's real numbers greater than -4 because it has a bottom. It's not going to go any lower than that -4. Okay, let's do some matching. Let's decide if we have any of these that are real numbers, less than or equal to, greater than 0, equal to 0, what we want to do. So take a look at these for a few minutes. Let's see if we can cross some of them out. Well, let's start with this first one. So I see that my x's start at 0 and they go this way. So if I'm looking at my x's are greater than or equal to 0. What about my y's? Are they going to keep going forever? They're going to keep going forever. So do I have something where I have an x value that's greater than or equal to 0 and my range is all real numbers? I do. It's this yellow one. Okay, what about f? Well, I see an open circle. So this time it's going to be greater than 0. It's going to be greater than 0. And then, is this going to move off that line? Yeah, I don't think so. 1, 2, 3, 4. It's a horizontal line. It's a slope of 0. So that means the y is going to stay 4. So you're right. It's going to be this blue one, the blue-purple one. What about the last one? Yeah, the domain is going to be all real numbers because it is a quadratic. And it's going to keep going up and up and up. But where does it stop here? Stops at 0. Is it going to be bigger than 0 or less than 0? Yeah, it's going to be bigger than 0. So do I have something that has a range that is bigger than 0? And it's all real numbers for the x. Yeah, it's the gray one. Okay, let's take a look at this table, and let's try to figure out what's going on with this. So let's go ahead and do some graphing. So we have 0, 68, 4, 59. It's going to be about in the middle. And 8, 54, 12, 50, 16, 47, and 20 is 45. All right, so my graph is coming down something like this. So it's definitely not a linear. So I see that my pattern of the x's is +4. So I know it's not linear. It is curving. Okay. Is there a pattern to the y value? So like 68 minus 9, that's minus 9. This is minus 5, minus 4, minus 3, minus 2. It kind of has a pattern. It's going 5, 4, 3, 2. So I can probably assume that I can fill in the next value. So this would be 24. And if the next step would be a minus 1, so this would be a 44. And then 28 would take me to a 43. Would leave me at a 44 because it would be a 0. Okay, it would be a 0 because I wouldn't change. So then what's happening here? The pattern of the y is decreasing. But is it going to stop? Is there a point where it stops? So let's talk about this. Let's look at the scenario here. It says the table is showing the temperature of a cup of coffee cooling over time. So if your room is a constant temperature, is your coffee going to cool down and turn to a chunk of ice? No, it's going to cool down to a constant temperature and stop. Okay, and stop. So what happens if we see that this comes down and we see that it's 0, it's not going to change. 0, then it's 0, and then it's 0. So the lowest temperature and where it's going to stay is going to be right at 44 degrees. It's not going to get any cooler than 44 degrees. Okay? Now, how does this change with domain and range? Well, this is a word problem. So anytime you have a word problem, domain and range changes. Okay, domain and range changes. So if I look at my graph, just looking at my graph, I see things changed. Okay, I see things change. Let's look at our domain. We're starting at 0. And is there a limit on how long my coffee can sit there? I mean, probably eventually it will all evaporate, but really there's no time limit on that. So I'm starting at 0 and I'm going to the right. So that would be real numbers greater than or equal to 0 for my domain. What about my range? Well, there's a starting point and there's a stopping point. I started at 68. And where did I stop? I stopped at 44. So I'm going from 68 to 44. Okay, so my range is going to be greater than or equal to 44, but less than or equal to 68. So again, we can use the real numbers in there to kind of help us. But there is a minimum temperature that coffee is going to drop to, and it's going to stop. Okay, so now let's kind of look at this function notation and domain and range. And this is going to lead us into the next part of your activity on your Desmos and your homework, where we're going to be looking at all different sorts of functions. You're going to be coming up with the values. We're going to be graphing and trying to evaluate, coming up with domains and ranges, patterns, that kind of thing. So we need our Desmos calculator would probably be the most helpful. So we're going to go ahead and clear out what we've got here, and we're going to put in f of x equals negative 3x plus 5. And I see I have a line. Okay, I see I have a line. And I am going to use my table function to be able to get my value. So at negative 3, and I can just change that number to a negative 3, it's 14. It already gives me negative 1. That's 8. It gives me 1. That's 2. And if I need the 3 value, I can change this to a 3, and it tells me that it's negative 4. So I'm going to go ahead and graph this. I can't graph the 3 and 14. That's too big. But negative 1, positive 8 is going to be here. And 1, 2. And 3, negative 4. And I've got a line. So let me draw that line in there. Coming right down through those points. Okay, so now let's use this to kind of answer some other questions about the function. So it starts with the shape of the graph. Well, it's a line, so it's linear. What is the pattern of the x? So I see that the x values are plus 2, so that's pretty simple. How about the pattern of the y's? How am I going from 14 to 8, 8 to 2, 2 to negative 4? Well, I see that 14 to 8, 8 to negative 2, that's minus 6. So I am subtracting 6 every single time. And what do you notice about the pattern of a linear function? Well, it's adding and subtracting. Okay, it's adding or subtracting, which is important because it's linear. Now we know that domain and the range on linears are always all round numbers. There are no limits. I could go on forever. I could go over here on my table and put in 5,000, and it would tell me what the value is. I could also put in negative 50, and it will tell me what the value is. There is no limit on my x and my y. Okay, how do I figure out f of 15? Well, remember, that is just substitution. So I'm substituting in for the x. So negative 3 times 5, that's negative 45, plus 5, oh, that's negative 40. Let's check our work. Let's change this value to negative 15. And that is 50. Let's change it to a positive 15, which is what I need. And that is negative 40. Okay, let's do one more together, and then I'm going to cut you loose to work on this on your own. Okay? So we're going to start with this one on the right, where we have x squared plus 1. So let's go ahead and get rid of these. We're going to type in f of x equals, and remember, if we need x squared, so we can use the x, and there's my squared, and look how it already curved. And I need to add 1, so plus 1, plus 1. Okay, so let's go ahead and create our table. And I need negative 3. Negative 3 is 10. Negative 1 is 2. 1 is 2. And I need a 3. And that's 10. Okay, so I'm going to go ahead and graph this. And it needs to look like my graph. Okay, so I know that at negative 3, I have 1 at 10. And at negative 1, I have 1 at 2. And then it turns around right here at the 1, 0, 1. And it's going to go back up. This one has symmetry. So it actually is a mirror image of each other. And I'm going to go ahead and draw this. Okay, so easily, it's not linear. It's a curve. Okay, it's a curve, so it's definitely not linear. Pattern of the x is still +2. Well, what happened here with the y's? Went from 10 to 2, 2 to 10. So it decreased, and then it increased. But it also has what we call symmetry, which are the same numbers. Okay, so if we see the same numbers, we want to say that it has symmetry. Okay, domain and range. It's a quadratic. Can I put in other numbers of x? Can I put in 50? Yep. Can I put in -50? Yep. So that means my domain is going to be all real numbers. What about my range? Does it have a maximum or a minimum or someplace that it stops? Yeah, it's stopping right there at the 1. So real numbers, it's going up from there, greater than or equal to 1. Greater than or equal to 1. Okay, so keep going with this. Finish up your Desmos activity. Reach out to us if you are struggling. And got a quiz coming up, so please take your time and do a good job.